Okay, so we're going to think about expanding brackets and the opposite process of that, which is called factorising. We've already seen a bracket like this, and to expand it, I'm going to use our box method where we visualise this as being a rectangle with side length 2 and other side length x plus 6. So if I split that up, I've got this area 2 times x, which is 2x, and this area 2 times 6, which is 12. So the total area is 2x plus 12. So 2 brackets x plus 6 expanded is 2x plus 12. But what if instead we were given 2x plus 12 and asked to factorise it? That means asked to write it with brackets, with all of the common factors brought to the front. Well, here's an example over here, 4x plus 12, where I'm going to try to factorise it. So I'm going to start with my rectangle again. So let me draw my rectangle. But I have a problem because I don't know what length this is going to be. I'm going to look at my numbers 4 and 12 and think, what do they have in common? So each of them are divisible by 2. So let me make this side length 2. Well, I want this side length to be 2, and for this area to equal 4x, and this area to equal 12. So for this area to equal 4x, it has to be 2 times something that makes 4x. Well, it's 2 lots of 2x. And for this area to be 12, it's 2 lots of something to make 12, which would be 6. So I can write 4x plus 12 as 2 brackets 2x plus 6. This length 2, this length 2x and 6 plus 6. But there's another way I could write that. This length instead could have been 4, because 4 goes into 4 and 12. So let me try that with 4. Again, I'm going to split this up. This area we want to be 4x, and this area we want to be 12. We get that from the expression we're trying to factorise. And so 4 times what makes 4x? Well, that's 4 times x. And 4 times what makes 12? Well, that's 3. So this would give us the expression 4 brackets x plus 3. Now, if we were to expand that, we can see we'd get exactly the same as what we started with. So both of these are valid factorising. We've factorised 4x plus 12 in two valid ways. But only one of them is fully factorised. Only one of them has taken out all of the factors, because if we look at this bracket, there's still a common factor of 2 in here. Whereas down here, there's no common factor left in the bracket. So when we're asked to factorise, we want to make sure we fully factorised, and that means we're looking for the highest common factor, not just a common factor, but the highest one.